Okie doke, folks. We're going to take a look at a little bit at analytic geometry, or what some people would call coordinate geometry. So being able to do things involving geometric shapes and figures and things, but in the coordinate system. So with like ordered pairs and graphing them. So two of the biggest formulas that we use throughout all of our shapes are distance formula and midpoint. So like on a test like the ACT, both of these formulas would be really important to know and be able to use on the MCA as well. But on the MCA, they give it to you on the formula sheet for distance anyway. They never give you midpoints. Let's talk about some easy ways to remember each of these. If you talk to somebody about what a midpoint means to them, most people would be able to kind of discuss and talk about that it means the middle of the line segment. So being able to find the location that was in the middle, so that would be the midpoint. But a better way, I think, for people to think of it, so to help with the formula, is think of it like an average. It's the middle, meaning the average. So how do you find an average of two numbers? Well, you add them and divide by 2, and that's exactly what the midpoint formula is telling you to do. Average the x's and average the y's. People really struggle memorizing formulas. So think of it as an average. That's what a midpoint is. It's a middle. Okay, now distance formula, I want to do the same sort of thing to give you the picture idea. I'd like you to go ahead and make 2 points. So I'm going to call point number 1 and point number 2, and go ahead and draw on the line segment. What I want to be able to talk about is how do we find that distance between them. So what we know about them is if we are doing this analytic geometry, we know their coordinates. We know their ordered pairs. So we know something about the points. So the reason we use the subscripts, remember, is because otherwise you wouldn't be able to tell the points apart, right? So if they both just said x and y, it's like, which one's which? So we need to know what those ordered pairs are. So how do we find the distance? Well, I'm going to go ahead and make this into a right triangle where the D is the hypotenuse. So I'm going to go ahead and drop the perpendicular down, make this a right triangle where the D is actually the hypotenuse. Now, I'm going to ask you a couple of things about what we can figure out here so we understand what the distance formula means. How would you figure out the height of this triangle if you know the ordered pairs of the points? Which coordinate would you be using to figure out that vertical change? Well, it'd be the y values, right? So how do I find out how far apart these y values are? How do you find out how far apart any two numbers are? You find the difference between them, right? That distance or difference. So y2 minus y1, I'd find the difference. That would give me the height of that triangle. How would you find the base of this triangle? Well, that would be the change in the x's, right? The horizontal change would be the difference between the x's. So how do I find the distance between them? Well, again, I subtract. Okay, well, if you know that those would be the lengths of the sides, what do you know about the relationship between the 3 sides in a right triangle? Well, the Pythagorean theorem says, if I can spell correctly today, Pythagorean theorem says a squared plus b squared equals c squared. Well, I don't see any of those labels in this question, but leg squared plus leg squared equals hypotenuse squared, right? So I would take the x2 minus x1 squared plus y2 minus y1 squared equals d squared. Well, then I want d though, right? Not d squared, so I square root. And that, my friends, is where the distance formula comes from. So it's just Pythagorean theorem in a right triangle that's been graphed in the coordinate system. If you remember distance formula that way, you don't have to memorize a formula. You can just think, oh, it's Pythagorean theorem. I know how to find those lengths. Okay, so just really quickly so we make sure we understand how to do these calculations, then we'll get into some applications. So when you're trying to find the distance between 2 points, it doesn't matter which one you call point number 1 and point number 2. You just need to subtract them. So I'm going to go ahead and subtract this way, but you can decide whichever way you want to go. It doesn't matter. So I'm going to say that I'm going to subtract in this order. Okay, then just do the arithmetic. Be careful. So we'd have 14 squared plus negative 1 squared. So that would give us 196 plus 1. So it gives us the square root of 197. The biggest issue that people run into, obviously, is just the calculations get haywire with the sign, so just be careful. All right, let's talk about how we can write our answer. Square root of 197, that's an exact answer because it's a radical, it's not rounded, which is really nice if you need precision like that. What you should do is always check to see if you can simplify. So check to see if you can simplify that radical. I don't think you can for this one. I don't think there's anything that's a perfect square like a 4 or a 9 or a 16 that divides in there evenly, so I think that's as much as we can do. But if someone wanted like an approximation, like if I was trying to tell someone a distance that they needed to travel, I probably wouldn't say, hey, go square root of 197 miles, because they'd look at me funny. As much as I'm a math nerd, I probably wouldn't do that. So what is another way you could write the radical? Well, you can write the decimal equivalent, right? So that's 14.04. Try it on your calculator to make sure that's good. So I could say to someone, hey, it's 14 miles away, about. So we can get an approximation. So depending on what you're going to do with the number, you can decide whether an exact answer or a decimal approximation is okay. All right, so let's take a look at a midpoint just to make sure we can practice a midpoint situation. So find the midpoint of the segment that has endpoints at -5, 4, and 7, -2. So remember, it's the average of the x's, the average of the y's. So to average two numbers, remember you add and divide by 2. So it looks like that would be 1, 1. Take a look at the arithmetic. So let me give you an example of a situation where you do something like that. So say you had the endpoints of a diameter of a circle. So say that those 2 points were the endpoints of a diameter. What would the 1, 1 represent of that circle then? Well, the midpoint of a diameter of a circle is its center. So we'd be able to find things like center by doing a midpoint. So again, an important calculation to be able to deal with. Okay, so let's take a look at some applications. So this is really where we use some of this coordinate geometry then. So to determine whether this quadrilateral with those coordinates for endpoints or vertices is a parallelogram. So first of all, what does quadrilateral mean? So quadrilateral means four-sided figure. And then what's a parallelogram? What do you know about parallelograms? So think about that for a second. The opposite sides in a parallelogram have to have two things. They have to be both congruent, which means equal, and they have to be parallel. So if you're going to do a question like this, what would be probably the first thing that you would do? Well, I don't know about you, but I'd probably graph it, right? So whenever they tell you something about a picture, go ahead and do the graph so you can see what the picture looks like. It's always easier to kind of get a gut feel if you're looking at a picture of something instead of just reading it. So let's go ahead and get this thing graphed here. All right, and we'll draw in that picture. Now, gut feel, does that look like a parallelogram to you? Sure looks like a parallelogram to me, right? So I think that this is definitely something that would look like a parallelogram. So what do I need to prove then to show that this is a parallelogram? Well, opposite sides need to be both parallel and congruent. So I'm going to color code here. So what would I need to show to make that happen? Well, the measure of QR, I need to know what it is, and the measure of ST, and they would have to be equal to each other. So I need to make sure I'm color coding in green here. The slope of QR and the slope of ST need to be the same as well. All right, then for my other ones, I would need to take QT, it's a cute little line segment, and then RS and see if they are the same, those longer ones, and then also the slopes of those two segments. So here's what I'd like you to do. I want you to think about how can we make those calculations? Well, how would you figure out how long they are? Well, then we would need to know their length, so we need the distance formula. And then how do we figure out if they're parallel? We need their slopes. So I already kind of jotted that down. So I need you to go through and calculate the slopes and the lengths of each of those segments. So go ahead and pause the video and see what you come up with for each of those. Okay, so coming back together here. So I got 2 square root of 2 or square root of 8 for each of those two segments, and then the slopes I calculated to be -1. Now, there's a couple different ways you could calculate slope. You could just count down 2 over 2, right, because you have the picture. Or you could have used the slope formula, rise over run, but if you have the picture and the numbers are nice, you can just count. All right, then the other one I think ended up to be 6 square root of 2 for each of them, square root of 72, and their slopes were +1. So those were equal as well. So is this a parallelogram? Yes, it is. And why is it? Because opposite sides, opposite sides are congruent, means equal, and parallel. Now, not only are they congruent and parallel, let's take a look. The slopes are 1 and -1. That means when you multiply them together, they are opposite reciprocals. They get a slope of -1. And if you think about it, this is actually a rectangle, because wouldn't those be 90-degree angles then? Because those two lines are perpendicular to each other. So like QR and QT, that would make a 90-degree angle. So this is actually, in fact, not even just a parallelogram. It's a rectangle. So there you go. All right, let's try another one. Let's talk about a different sided figure. So we did a quadrilateral. Now we're going to do a triangle, so a 3-sided shape. It says prove that the vertices, or the points with those vertices, makes an isosceles triangle. So the first thing that you need to know is what an isosceles triangle is. So what does that mean? It means two sides are congruent. I'll use the symbol for congruent here so we know what we're talking about. So again, just like in the last one, I think whenever they tell me something about a shape, I'm going to go ahead and draw it so I can think about, just kind of get my gut instinct going here, because we can tell a lot from that. Let's take a look. So this triangle ABC. Now, this one's kind of tricky. The last one was pretty obvious. This one, it's really kind of hard to tell. Is that really isosceles? When people rotate shapes, and it's not just horizontal or vertical, it's really hard to tell. So let's see what we need to prove or to show. If this is going to be isosceles, I'm going to have to do some calculations here. I'm going to need to know what my three sides of the triangle are, and then I can make the determination if two of them are in fact equal. So we need to do the distance formula for each one of these. So we're going to have to go ahead and do that subtraction and do the distance formula. So subtract, square, add them together, do all that work, and see what we come up with. So again, I want you to pause the video, go ahead, do distance formula, and then we'll check back in with what numbers we're getting. All right, so for AB, I got the square root of 136. So it's the longest side of the triangle, not going to be equal to either of the other two. The other two I've got for both of them, it was kind of hard to tell, but they are in fact exactly the same. So they are both square root of 68. Now maybe all of these could be simplified, but for purely saying whether it's isosceles, I don't really need to simplify them, I just need to know that they were equal. So yes, this is an isosceles triangle because two sides are congruent. Or you could even say that AC is congruent to BC, if you want to be very specific. Okay, last one we're going to do is we're going to talk about area. So many different applications with the things that we're doing for arithmetic here. But I'm asking you to find the area of a parallelogram. So I want you to pause the video for a second, make your picture, see if you can figure out what the area of the parallelogram would be. First of all, how do you even find the area of a parallelogram? Like, what do you need? And then do you have that from the picture? So go ahead and pause the video and see if you can make your sketch and do some determining here. So when I make my sketch, I'm going to go ahead and get those 4 points on here. So they're telling you it's a parallelogram, which it definitely looks like a parallelogram. And we need to find the area. So we need to figure out what the area formula for a parallelogram looks like and see if we can get that from the picture. So I'll just draw another parallelogram over here so we have something to start from. So what is the formula for the area of a parallelogram? Well, what shape can you turn a parallelogram into? Some of you might remember this from geometry. If I drop the perpendicular down and look at that cute little triangle that I would get on the end, and if I take that triangle and scooch it over here, you end up getting a shape that looks like this, which is a rectangle. So if you remember the area formula for a rectangle, base times height, that's all you need for a parallelogram as well. So let's take a look at our picture and see if we have a base and a height. So the base looks like has a length of 7, and the height looks like from the picture has a height of 4. So my area would be, 7 times 4, so that would be 28 square units. So this one was really kind of nice because it wasn't rotated. This shape was actually horizontal and vertical for the base and the height, so you could just count to figure out how long it was, and I think that's how a lot of people would do it, just how long is it? So we can figure out each dimension. Could you use the distance formula? Absolutely, that would work great too, but we don't really have to. We can just look at the information that we're given and we could just count. Now, if you rotated the figure, whole different story. You would have to use the distance formula because you wouldn't be able just to look and say, oh, that's a horizontal or a vertical distance that I can just count. So we definitely have the distance formula in our back pocket to be able to help with that. So using distance and midpoint, lots of different applications for those, especially in geometry, so we'll continue to use those.